let's get going now. So you have, um, so there's a homework due Monday. Hopefully you saw the announcement. And sorry, it keeps shuffling the locations on me in Blackboard. Obligatory, I don't like Blackboard statement, which is becoming probably annoying at this point. So there's this Hw3 Initial Requirements. I have it due on Monday, so please be sure to check that out. Should be straightforward. Just write 3 functional and 3 non-functional requirements. If it doesn't feel like a lot of effort for a homework assignment, it used to be a bigger one. So it has part individual and part group. And I split it up. You'll get the second half after the exam. I didn't want to, freak everybody out with work to be done prior to the exam because I know you're all going to also be busy studying, or at least I expect you would be. But kind of the group part is after the exam, yes. So basically, just kind of the idea is it gives you how to write a requirement, and we're going to do an in-class assignment at the end of class today for writing requirements. But I'm just looking for 3 functional and 3 non-functional. Be very careful with your grammar and your spelling, and make sure that your requirement is extremely specific, right? So I shouldn't be able to, I shouldn't have to guess what your requirement is doing. So that's the purpose of this part. Part 2, you're going to come together in your groups and you're going to write some initial requirements for your projects. That will be after the exam. And basically what I'm going to be looking for your teams to do is to take these requirements that you all have written up separately and mash them together into a single document, which will form the core of your requirement spec. So basically, if you do a good job with this group assignment, that's one section of your term project write-up that is pretty much done, short of any revisions that you need. So there you go. Part 1 of your write-up nearly done. And one other thing to look forward to after the exam, I don't have a specific day in mind yet. It will probably be the week following at some point. We'll do a Zoom session where I will have each team do like a quick summary of their project, where they're at, um, maybe try to show whatever they have at this point, kind of like a initial status update type of thing. And that way everybody else can give you feedback too. So we have that. So we have homework 3. Group homework will be due after the exam. I'm not going to make it live until the exam is done, so you don't even have to worry about that. And then we'll have some little presentations after the exam too. Announcements to follow on that part. And again, exam is on Wednesday. Study guide is on Blackboard. We'll have probably 20 or 30 minutes or so to talk about this on Monday as well if you have any lingering questions, things of that nature. And again, at the end of today, somebody please stop me at about 9:30, assuming I talked that long, but we will do the in-class assignments that we didn't get to last time. We'll do that at the end of class today. And what we'll do on Monday is we'll start with a discussion of what your teams all submitted to. Sound good? Notes, please. Come back. Come back. Start with the requirements overview. Hey, don't these look like very professional professor notes? Yeah, do this. Nobody needs to hear that, so that's good. All right, so let's start talking about requirements representations. We went over functional requirements, we went over non-functional requirements. We talked about elicitation last time, which is again the process of figuring out which requirements you need. And the spoiler is what you guys are doing right now with this write 3 functionals and non-functionals. This is basically the elicitation phase. You're trying to figure out what your team needs in terms of requirements. So basically, You're going to elicit them from yourself. You're just pulling it out of your own head. Depending on your team makeup, maybe you do a discussion, see who's working on what. It's not required at this point, but maybe you've had some discussions about your term projects, what directions you're going, and you'll be pulling from that. And then you'll revise them as you go to be cleaner, clearer, and kind of gel a little bit nicer. But we have prose requirements at this point. We also have a lot of other representations that we can use as well. We'll come back to that. And what this is kind of wading into is something that is often very painful for students and faculty alike, because this is getting into the UML diagramming aspect of software engineering. And if you have worked, you're going to roll your eyes when I say UML. If you have not worked, you're going to not have any clue what I'm talking about, so that's fine. It's just going to be another thing to learn. UML diagramming has a very weird place in industry right now. There are some companies that actually do UML diagramming. They think it is beneficial. There are some companies that think it is a complete waste of time. But the purposes for teaching it in here is that it's good to get experience with these things and to really understand how to break down projects and break down requirements and things of that nature. So basically what we're doing is we're abstracting out pieces of our process and we're diagramming them and we're modeling them. So quick question, any of you ever do a UML diagram before? And if so, what have you done? Hmm. I guess I should say some of you probably have if you've done a class diagram. Would that be it, Jacqueline? Like class diagrams? Okay. Yeah, okay, good. So you know one type of UML diagram. There are a lot of UML types. Class diagrams are very helpful for figuring out how your implementation fits together. And you probably had mixed feelings on class diagrams when you're doing them, right? It was probably extra effort, somewhat annoying, probably painful to be graded, depending on how nice your teacher was for that. But you can see it's like a layer above programming. Now, with some of these diagrams, you can do automatic things with them. Like you can automatically write code from a UML diagram. There are tools which take the class diagram as input and spit out code. It's not done. I mean, you have to actually fill in the blanks for these types of tools usually, and sometimes they're worse than you think they would be. But kind of the idea is you're getting your plans for how you're going to write code, how you're going to implement a project down on paper. And with these diagrams, kind of the key takeaway is that everybody can more or less understand them. And think of it this way. Maybe you as the technical expert think it's a waste of time, and I'm going to play devil's advocate that you don't want to do UML diagramming. I'm not trying to poison any of your opinions here, but let's say that you have no desire to do it. But you have to work on teams with people who have no idea how to write code. They don't know what a loop is. They can barely understand how to use a mouse. Okay, maybe they're extremely technically illiterate. You can push a diagram in front of them and walk them through a program flow. Okay, the user is going to open the application here. They're going to click the login button. That's going to take them to our login screen. The login screen will talk to our backend database. And you can do that from any level of abstraction. Class diagram is very, very detailed. It could be blown way up in terms of how detailed it is too. Get into something like a behavioral diagram where it's just showing intended behaviors when you do X versus Y versus Z. So these diagrams are going to be going into today, Monday, and after the exam. We'll have a little bit of time with these. Mainly it's to enable communication and understanding. That's like the whole purpose of these things. They will be artifacts. They will be things that you check into your configuration management tool. You do not have to use all of them. UML is a standard it's like an IEEE standard, and there are a whole bunch of different diagram types. But if you look at these less in terms of extra things you have to do, just to move life along in your project, and more as a tool for helping communication and helping with understanding, they can actually be kind of powerful. But again, it's extra effort. Not a lot of companies want to invest that time when you could be writing code for something else, or you could be writing test cases, or you could be talking to customers. It's kind of a big divide, I suppose. So just basically know what you're getting into here. Um, so with that, we're going to go over some of the different types. We'll talk about systems as a whole. We'll talk about some of the different diagram types and how we create them. And then we'll be getting into details about some of the more common diagrams. I guess another thing too, if any of this tickles your fancy, a lot of academia and software engineering research tends to do a lot of diagram level types of stuff. So basically, if it's something that you like, I know there are some faculty here that like working with diagrams. I like them for testing. Professor DeVries likes them for formal verification type stuff, and I'm sure there are others too. Anyway, let's look at some of the different types. So I've mentioned these are really for enabling communication, and you're really trying to kind of visualize your systems as a whole or different pieces of your system. So they're basically visualizations of particular things that you want to do, that you have to implement, interactions, sequences of operations. There's a diagram for everything. So we have two different types. We have the structural types, which are basically the static aspects. So not to read the slide, but these are the things that are basically implementable. So a class diagram would be a structural diagram, to kind of put that into context for you. You are specifying how your system is built, how it is structured, which is where the name comes from. Class diagrams being one of those. We also have the behavioral side, where this is the things that are changing. So these could be communications or messages being passed. Maybe it's behaviors of a particular component, right? What is this thing actually doing? What is it expressing? Class diagrams are easy, right? Attributes, data types, methods, how this class talks to this class, but you're not saying behaviors, right? You just know that class cat is a animal, or class dog can bark, but that doesn't really tell you anything other than, okay, I need to put these variables here. This needs this particular method. Okay, this one's private, this one's public. Structural, nothing dynamic, nothing changing. But with these diagram types, they keep coming back to this word system. So visualize, specify, construct, document a system. Static aspects of a system, dynamic of a system. The question is, what is a system? Because in the engineering domain, in the computer science domain, we actually have to define what these terms mean. Otherwise, they have zero context. You know, my system, the example from way back, those other professor slides I was using a few 3 or 4 modules ago, system was the human body, right? We were talking about the lungs and breathing, and the boundary is, the outside of my body. That's the system. So here, what we're going to consider the system to be is anything specific to this particular project that you are working on. So it could be your code, could be the hardware that is running your code, could be other stuff that you are using, interacting with, pulling in. Basically, it is something with a well-defined boundary that encapsulates your thing you are building. So I saw in your project proposals, and you all got project proposal feedback, by the way. More or less everything was good. Some people I want to push a little bit harder. Some people I want you to scale back a little bit. But overall, project proposals I felt were pretty good. So biggest hurdle you all have as teams now is communication with each other, making sure you're all on the same page. So slide aside. But I like your systems that you're developing. Anyway, so the system could be a Unity application, right? So I know a handful of you are doing Unity. Your system there is going to be all the code related to your Unity application. It's going to be your build packages that you use, whether it's being compiled for an exe, whether it's a WebGL application, whether it's being ported to Linux, but it's going to be all of the code encapsulated by this thing. Depending on where you set your boundary, that might include the user, the hardware that a user might use to interact with it. So maybe the mouse is going to be a part of your system, or maybe it's going to be an external system that you reach out to. The key here is that we have to really specify what our boundary is, what is our scope. And to get to this, we'll write it into our requirements spec, right? So, system encapsulated. The system may have an interface to other systems, right? So if we go back to that example, this mouse might be another system. My headset might be another system, right? Both of these things are running code, right? There's a little microchip on my headset, my mouse, keyboard. I don't have a separate keyboard right now, but these are separate systems. My game application or my whatever I'm building doesn't care where the mouse is. It just knows I need mouse coordinates or I need to send sound to a headset. Right? So I'll talk on an interface to these other systems, and then those things are encapsulated. Users, part of the environment. Physical world, part of the environment. You have this external stuff to your system. So let's go to a real world example. You're building a vehicle. Maybe it's autonomous, maybe it's not. Do you factor in the physical world into your system itself? No, that is an external entity, right? If you are driving here, I mean, this is a great area to talk about this, right? So let's get a Tesla with their semi-autonomous autopilot. You're gonna let it drive by itself. Today, looking outside, it looks gorgeous. Sun's shining, snow's probably melted off the roads. Should have zero problems driving, right? Can see the lane markings. It can see the road signs. Flashback to a week ago. Can't see a damn thing on the roads. Everything is snowed over, signs are frosted over or snowed over with the wind. How does this system function? That would be uncertainty, that's a different topic. But part of the physical world is that we have to deal with it. Okay, it's not internal to our system, but we'll document it, right? Maybe we have steps to handle that. Bit of a slight tangent there, but real world environment, things that we have to deal with in our systems, but they're external entities. So with all these, we're going to write requirements for pretty much everything, right? So if you remember the categories of our requirement specs, we're going to have functional, non-functional. We may have user level requirements. We may have requirements detailing what the environment is going to look like and what we can expect to deal with. System level requirements, again, we're going to have lots of different categories. Bit of an aside there, I suppose, but worth considering. So these are all the things we care about as software engineers, right? Hopefully that makes sense. So let's say that we want to maybe do some modeling. And the reason why you do modeling is that it will help you along with your software engineering process. Flashback to when we talked about waterfall and agile and everything in between, right? Each of these processes will have a stage where you're not strictly writing requirements, but you're trying to kind of get a handle on what your system is doing, how it's going to be built, maybe what tools you're going to use, maybe what ideas you're going to use, how everything's going to fit together. Modeling is going to help you along that path. So this would be like your architecture level, your design level. Basically, it's that level in between initial vision and scoping and detailed requirements writing. And again, depending on your process, move these activities around as you need, but you probably will have a step like this in some fashion. Depending on your company, you may do it differently. This is a one take on it. There are many, many different approaches. So let's look at a few of these here. Looks like we got 10 minutes before I'm going to kick you off into your groups. Remember, we had structural and behavioral. So these were the two categories of UML that we're going to be focusing on. And we're not going to look at every single one of these, honestly, because they each are their own thing and it'd be a lot to do in one semester. But just kind of take a look here at what we've got going on. So structural, there's our class diagrams, right? We also could talk about things like deployment diagrams. How do we actually take our software and put it onto hardware? We might be going up a level in abstraction. Let's talk about package diagrams. If you did a class diagram, I'm curious, did any of you do package diagrams? Because that's kind of like a layer above classes. And it's something I think you can auto-generate in like an Eclipse or an IntelliJ environment. Anybody do a package diagram? Question mark. I get concerned. Nope, okay. So this is a slight aside. You know how when you get older, you start talking to yourself more, like I'm gonna write out an email and I'm gonna verbalize it? I'm doing this intentionally on Twitch just so that there can be a correlation with what I'm typing. I'm worried that this habit's going to continue on when we go back to in person. I'm going to write an email. I'm going to push my glasses down. How are you all doing today? Oh, God. Unintentionally aging. Let's go with that. Ooh, I got a bra for that. Thank you. Anyway, so a package diagram, when so you all did Java on 163. I assume you remember creating packages, right? Because that's like part of your org dot your name dot however you structured it. That's your package. In programming, you can have multiple packages. This basically just says how do these packages link to each other. So the class diagrams would be inside the package. You can have multiple packages interacting in some way. So that's just what those are. Object, component, composite, these are not really things we're going to be getting into too much, but they basically just specify different structures. Oops. I've got the details here as well. Sorry about that. On the right side here, we have our behavioral diagrams. Now, use case diagrams are one of the ones that we will be going into we're going to focus on this one mostly because it's going to give you an idea of how everybody will be using your systems. Okay, so basically you're creating use cases. What is a use case? Professor logs into application. Professor is granted administrative rights so that he can break application. Multiplayer game server instance is created. Professor is given God mode in multiplayer game. So basically, you're just kind of listing out every single possible activity that can occur. And you try to generalize it so you don't have a million of these things, right? User logs in. That would be one generic use case. But then you specify who is interacting with the system. You're specifying what are the particular activities that happen for this use case. Okay, we can also have things like state machines. I don't know if any of you have ever gotten into state machines in your other classes, but this kind of shows a sequence of events. System initializes, system configures itself, system waits for user input, and it's going to be all about the different states of your application. And it's going to also say, how do you go from one state to the other? If I want to go from main menu to game, user clicks start game. Or if I want to go from the menu to changing the video settings, user clicks options. Be an action that happens, right? We're not going to spend a lot of time on state machines, as much as I would like to. They're a lot of fun, I think. But there are other ones too. Sequence diagrams, communications diagrams, interactions. These are all about users interacting with the system, sending data from one state to another. Basically, if you look at these, some of these end up being pretty similar in concept, but the particulars will be different. And one thing we should probably talk about here too is that with UML, so these are each different diagram types, they all have their own syntax as well. And what that means is, let me see if I've got a example here. So yeah, So this would be a use case diagram. I'm gonna guess some of you have seen this, and it doesn't matter that my face is blocking it. There's just another stick figure up here. So the syntax of this diagram means that users or systems, and I didn't mean to click there, sorry. The syntax of this diagram is that you have some kind of an actor, whether it's a person or an automated system. They're going to be stick figures. They're going to be connected to use cases, which are little bubbles. We're going to have specific terms for how bubbles interact with other bubbles, right? So this would be the syntax of this diagram. Just like code syntax, right? Java and C Sharp, pretty similar languages, but the syntax is different. That's just these specific words that you place so that your, say, compiler understands it. Same thing here. If you tried to make a use case diagram and you just did your own thing, I would have no idea how to read it because I can't, read your mind with what you're trying to get at here. Same thing with interaction diagrams and all the other diagrams. They have their own specific way of writing it. And, intuitively that's obvious, right? Of course, the diagram's going to have its own way of writing it. Mainly, I just want to say that's its syntax is kind of the thing. All right, so let's talk about a couple of these and then we will do a hard stop there and go into your in-class assignment type stuff. So let's look at a couple of the structural diagrams. So class diagrams, if you were in 163, which should have been a prereq for this, should be familiar with. That's the classes, that's the relationships, right? So those are attributes, specific classes, how they interact with other classes. Basically, I'm going to make the assumption that you know or remember that. And if you don't, there will be a little assignment where you actually write a class diagram later on too. We also have an interface diagram. So this is going to be directly related to class diagrams, but these are going to specify the operations for a particular class. So it's basically a different perspective on the class diagram. And then you might say, well, what's the purpose of having it if we already can encapsulate that in a class? Basically, it just gives you more detail on the operations that can happen. Class diagrams, kind of broad if you look at it from a structural perspective. Interface, a lot more detail on these services that it will provide. The object diagram, then, is also related to the class diagram. So these class interface object, these are going to be very, very similar in structure. But the object diagram is going to be an instantiation of a class. So if I do your typical dog, cat, animal, that's your inheritance example for classes and object-oriented programming, that kind of stuff. If you don't remember it, I think we'll be talking about it soon when we do class diagrams. But the class is like the generic side. The object would be an example. So if I have an animal class and a cat class and a dog class, the object diagram for the dog would be the dog's name, its weight, its type. So this would be, I don't know what a good dog name would be. Go with my old one, Mac. So he was a good dog. He's a good boy. Mixed breed, 60 pounds. Object diagram would be the instantiation there. Class would be the generic side. Then just to wrap up the slide here, component and deployment. So these are like high and low level respectively diagrams. So these are basically going to be kind of a layer above classes. So high level functionality of your system with very specific types anyway. So do I have that component diagram would be here. We're not going to do a component diagram, so don't worry too much. But you're going to have things like components, component staff, component map. So these are basically like almost like packages. And then there's going to be how we interact with them, what state they will be in. Again, this is kind of a high level. Let's figure out how classes, how packages interface with other things. Then the low level would be, I don't have an example of a deployment diagram, I don't think. Yeah, I don't have one here. Basically, it's just going to be how you take these objects and actually deploy them as a real world resource. And we'll do some abstraction here too. But just kind of the key takeaway here is not to get freaked out about how many diagrams you have to deal with. but to understand how to pick and choose which ones to create. Because you don't necessarily need every single one of these. But what we'll do is we'll pick up next time with more diagramming. And we'll kind of go into some of these other types as well. And we'll go into like examples of what these mean. But I want to give you enough time to do your assignment. So this is going to be another one of those, go over to Discord and pick a random room. So I've got a, let's see. Where'd it go? Those are all your teams. Okay. Group 1 through 4. So I created new rooms, so I cleared them out. What I'm looking for here, I need 4 requirements from each group. So 2 of them should be functional, 2 should be non-functional. Now pretend I'm a project manager who is telling you, my peons, who are getting paid for this, hopefully, that I need a web application. It's both a customer and employee front end to a backend database. So what this means is customers will log in, employees will log in too. Naturally, we are the largest retailer of home improvement products, and we have a logo that is quite different from orange or blue, so we are not Home Depot or Lowe's. We are our own massive big box lumber store, home improvement store. What I need, customers have to search for products, see what is available in stores near them, be able to purchase those products. So basically your typical log into Home Depot, log into Lowe's, absolutely. Low Depot, there you go. Perfect. So you have to be able to do standard inventory stuff, right? That you would see from a customer side. Employees log in, update the inventory, store that information, and log their hours. Oops, I didn't update this. It's 2021, not 2020. We want any device type, any screen size. Users should experience absolutely zero loss in productivity, loss in functionality. So basically, this is what I need you, my team, to go out and build. Where do you start? Start writing requirements. So pick a Discord room. And again, I've got those created for you already. And discuss which 2 functional and which 2 non-functional requirements you want to implement. Yeah, specifically different groups. So this is intended to kind of be a, I guess I take that back. If you want to do it in your project teams, that's fine too. But I created the 4 rooms for you all to go in. 1 submission per group. Just put all of your names on it since I am making this kind of a random assignment for people. Make sense? So let me clarify here. Hop into Discord, join one of the 4 Discord group channels, or your team if you prefer. 2 functional, 2 non-functional. Okay, instructions in chat. So this is due by tomorrow night. So again, if you happen to miss class and you're watching the recording, you can still submit it. I should specify too, while you are all kind of thinking about which rooms to join. Okay, I see activity happening. That's good. I don't care which aspects you focus on, right? You could probably write 50 to 100 requirements just from this paragraph. I'm just asking you for 2 of each. And again, with requirements, make them crystal clear what you are doing. Make sure they're testable. All right. If that is good, let me put on some thinking music here. get a little bit less grading. And I'll pop that back up for you. I'll kind of bounce in and out of some of the rooms too to see if there are any questions to address. All right, but he's looking good so far. And if there are any questions from anybody, feel free to at me in Discord and I'll come try to handle questions. debating if I should give live feedback on some of these that I'm seeing come across or wait until Monday. We'll talk about them on Monday. Oh, somebody made a table. Nice. Let me know if the background music gets too annoying. I tend to go with synthwave, cyberpunky type stuff is a nice compromise for everybody's tastes. And then you're like, what background music? Because you have the volume set so low. Can you explain the difference between functional and non-functional again? Sure. Oh, sorry, I must have missed that. I was looking at the various groups. Excuse me. So functional should be very, very clear about how something should be implemented. Or it should be very specific about a particular functionality of your system. Non-functional should be something a little bit more about maybe the look and feel of the system, or like a high level impactful goal that would like deal with lots of stuff, I guess. Non-functionals were like security, usability, performance, things of that nature. So functionals are extremely easy to quantify or easy to test. Does that work for you? Oops. Oh. We have a list UN expansion. I just want the list. So that's all you really need. Again, it's meant to be like an in-class assignment, so. Just make sure you put all your names on it so I know who to grade. I do like what your teams did, though. You all popped right into Google Docs. Maybe I should just have like 3 or 4 documents set up for sharing and just have you go right into those. Although I like the discussion happening in Twitch or in Discord too. I've been pinged. Can you take a look at ours? Let's see. I am in there. Okay. Yeah, you don't have to go super deep. All right. Okay, so group, which group am I in here? Group 1. I would say as a start, that's probably pretty good. Technical writing could use some extra love, but overall it's good in concept, I would say. If that makes sense. So let me give you an example. I'm going to pick on you, your team, since you asked for help. So you have a non-functional that says needs to be usable across any device regardless of screen size or type. So I would say that's a good one. Better way to write that would be system shall support any device regardless of screen size or type. So needs to be usable is kind of a very informal way to say that. And I'm not... Technical writing means to use active voice, to use don't use words you would commonly speak, I guess. Verbal versus formal writing, I guess. It's something that takes a while to get if you're new to it. I'm not going to mark you down or anything like that for this since it's an in-class type of thing, but kind of the biggest takeaway is that you need active voice for technical writing. So it's going to be like noun, verb, something, not because of this, you should do this. User will do this because of that. Technical writing's a whole other thing, but I'm going to try to force you all to pick it up in here a little bit. All right, we have officially ended class for today, so make sure everybody's name is on that again. Great job, everybody. Love seeing all the activity in Discord for what you all did there. Yeah, okay, good job. All right, I will see you all on Monday. And have a great weekend. I think what else? Yeah, have a great weekend. Looks like it's going to be a nice one. Bye, everybody. Our professor does that for each class. Constant email notifications are kind of annoying. Oh, okay. I can see that. All right. Bye, everybody.